opportunities available not only nationally as well as globally, which students should start from the first itself.
So for what I would suggest is first target startups. Once you are done with startup internship, target good places in India like ISRO, DRDO. Uh, and once you are done with that, because in getting in ISRO and DRDO is also very easy. It's very simple. Just have to apply and they generally select if you have good experience. And once you are done with that, then I will suggest you to go to international internships because if you can show ISRO, DRDO in your resume, they will definitely hire you.
Okay.
Solid propellants, they are very risky to work with because in while cooking the propellant, people lack knowledge. And students definitely they lack knowledge because they have not gone through any course or something. And liquids. Liquids are very complicated, very, very, very complicated. You should because if you see just one diagram, like the schematic of a liquid rocket engine, it will take you a week to understand what all things are there. So I will say in the hybrid rockets, the fuel part that is in solid state, so it is stored in the motor, in the like a solid propellant. And the oxidizer, which is in liquid or gaseous state, for example, just take oxygen, it is stored in cylinder outside. You just need one connection between them, one non-return valve, one check valve, or check valve, and one the flow control valve, so that you can control the flow rates. And you should have an igniter because oxidizer and fuel both are separate and far away. There is no chance they can mix together. Sure.
Hello everyone, this is your host 𝗙𝗵𝘀𝗲 and you are watching Space Science Podcast Series 5. So I'm on a mission to connect youths and all the space learners with and providing a platform for a better career and better thinking out for advanced career opportunities out there. So without wasting our further time, let's invite our today's guest, who is someone of our age or more, maybe 2 years older than us, and he is a student from IIT Madras. Not only this, he was the propulsion lead of Team Abhyuday, and we have heard about it a lot. So I personally admire that. And at the end, one more thing which we should not miss out is that he is the part of India's first and Asia's largest student-built hybrid rocket engine. So that's very fantastic. And I think we should not waste our time. And let's introduce Mr. Siddhesh Dileep Yadav. It's great to have you here. And if I would like to start on with my podcast, I would like to ask you a simple question, which people usually ask at the end. But I would like to ask
Okay.
at the first, so that what is that thing like you have inspired a lot of people with the work you have done till now? And personally, I also get inspired. So, what do you think the listener should take away from today's podcast so that they set the inspiration to others? So that's, can you please brief us on that?
First of all, thank you, Prachi, for giving such a nice introduction. And one thing which I feel that listeners should take away from here is a motivation and inspiration because some most of the time what happens is we have that will to do something, but there is no fire in the belly. It's like most of the time, even when we were starting the project of the Asia's largest student-built hybrid rocket engine, it was like very, I mean, we feel that it is very difficult and we might not be able to do it, and the consequences if we fail. Because if you blast, I mean, in the other, like for example, take the racing car and all those things where you build a device, if something fails, the system will die. But in the rocket system, if the engine fails, which is during the testing, if the engine blasts, basically you will die. So a lot of precautions and everything, there is a lot of difficult thing. And but what keeps us motivated is the end, is the final result that we will get at the end. So, and yeah, to start all these things, we should have a fire in the belly. It's like the you should not be just be simply motivated today and tomorrow you are like if something fails and I just give up. It should not be like that. It should be you should persevere. So if something happens, because when you have that fire inside you that I will do it at any cost, that might come due to several reasons. For me, it was something different. For other people, it's like someone have to show someone that I can capable of doing it, and there are multiple reasons. But the only thing is to develop the fire inside ourselves. That anger can lead us to long ways.
That's great to hear. And as you mentioned, you also had some spark in you. So, my first question would be with that only. What was that spark which you are talking about? What did actually sparked in your brain and still continues till now?
Okay, so firstly, my inside me there was, I mean, I was like I wanted to become a cricketer when I was in third grade, but later I started watching this Discovery Science where they used to have this program called as Strip the Cosmos, NASA's Unexplained Files, all this. And this they simply showed rockets flying, and those things motivated me a little bit. Then the good thing about my life was when I was in fourth grade, my friends used to be in 12th grade, so I had all knowledge of what to do after 12th grade and engineering domains. So aerospace engineering was something which I wanted to do. But yeah, but there was not much of facilities where I was staying when I was studying. So after 10th grade, I simply joined a coaching, just a local coaching where nothing good was taught, and I mostly relied on the online sources. But some things, I mean, I was mainly distracted in the first quarter of my preparation, but some things happened in the mid time which which brought a very deep fire inside me that I want to show this particular person who am I. So I mean it yeah, something happened which created a spark that I wanted to show them who I am. And this was about getting into IIT. So I got into IIT. Then about the rocket engineer. So I joined this Team Abhyuday as a volunteer in my first year, but there was nothing called as a rocket engine that we were talking about. It was just a body tube that they were building, some avionic stuff. But I personally wanted to because I came to IIT to make rocket engines. I had no other visions. Only thing was I want to make rocket engines. But there was nothing like that because in the labs there were no BTechs. BTechs were not taken mostly. And in this, there was only one team Abhyuday where they were not making engines because maybe no one was capable at that time, or maybe they didn't want to do because of the complexity and lack of knowledge, maybe. So I just wanted to do it somehow. So just the next year, we started this vertical called as propulsion. And I think some 11 people, 12 people were there. 12 of us were sitting on the ground in the Center for Innovation at IIT Madras, and we were discussing like how to make a rocket engine. We don't know anything. We were just discussing something,
Okay.
and a week later we came up with some initial calculation, and we 11, 12 were fighting with each other. But when the project was, and yeah, we are basically not doing great at that time. But as we progressed, this team started decreasing from 11 to it came to 8, 6, 5, and at the end we were only 4 left. So I mean, yeah. So that time I think I was the only one who was very active in terms of the testing and everything, manufacturing and testing. Because my vision was very clear. I don't because that was a lab scale small motor, and I want my vision was clear. I want to make a big 3 to 5 kilonewton engines, and things were not happening. It was like if it is getting delayed, then we are gone. Then we can't complete the big engine on time. So there is a good story about that. So before actually firing the engine, we need to test it with water. So because it's a pressurized system. So we need to fill the water and pressurize it using the hydraulic pump at a particular pressure so that there is no leak. If there is no leak, means it passed the hydrostatic test and it is good to go for the firing. So, in our case, in my team case, the small motor that we built, we did 3 tests in 1 week. All of them failed. And when the last test was failed, I was like, this is because I knew the motor was good. There was something wrong in the connection. So I was like, I will repair it alone. The whole night I thought, and there was a team with me, but I was fighting with everyone alone that I will do it. I don't care about anything else. And the next morning, 8 a.m., when the lab opened, I went into the lab alone. No one from the team knew that I was there. Everyone was sleeping nicely, and I repaired the motor alone. And when I pressurized little bit, it didn't leak. Means it was working fine. But then the pump was having fault. Then the pump was unable to pressurize. Then I opened the pump. I didn't know what I was doing, but I just opened the pump. There was something. There was a rubber inside which was cut. I replaced the rubber. I made a rubber from the synthetic rubber, I made the dimension of from the synthetic rubber a sheet and I put it, and somehow the pump started working. And I connected all the pressure transducer, everything on my own. My laptop was there. I pressurized it. Then it was supposed to sustain at a pressure of around 60 bars. But because in the gauge also it was showing 60 bar when I stopped pressurizing. But when I went into the control room and checked, it was 110 bars.
Okay.
And the motor was sustaining that. So that is, and then then I clicked the video and everything, and I sent to the team. And the current at that time there is a guy who was propulsion lead. So he was, bro, what did you just, you didn't inform if it would have failed. But I was like, I trusted the design. And then after that, for the firing also, team was a bit lazy at that time. So I had to convince everyone that this is successful. I want to fire today itself.
Okay.
So no one was convinced. So I had a very huge fight with my current at that time's propulsion lead, that I was like, I want to do it. I don't care about it if anyone is supporting or not. So I alone went to the shopping market that day, and there were some small stuffs missing out. I purchased everything from there, came back. Then next day, I convinced the team to help me. So there were some members of propulsion that time. They came, and morning 9 a.m. we started. It took 12 hours to set up because that was the first time. And night 9:43 p.m. the engine fired. Actually, the firing story also, before the engine actually fired, it got failed 3 times. Because the igniter was not working. Suddenly we were doing some work and the engine started firing. So that that was the moment. And this is what I mean, I had that fire inside me that I want to do it. I don't, because the team that time was not very much focused on this. So I wanted to do it at any cost alone. I was ready to do it alone. So I had that motivation. I had that thinking inside me. So sometimes what happens is if you depend on someone else, then things gets delayed. I am not that kind of person. If someone is not helping me, not giving inputs to my project, I work alone on the whole thing. So that is what something you should be capable of. That's why I became the propulsion lead and managed the whole testing of the 3 kilonewton or 5 kilonewton engine.
Oh, that's really great. You have covered almost all of my questions which I had in my mind. So I've completely blanked out. But when you were talking about that engine kind of when you went in the night and you did the stuff, I remember that Three Idiots movement, Amir Khan, which we
Ah,
always do, right? Sometimes that thing fix, but sometimes it doesn't. So that movement was coming in
yeah,
my mind, and it's so great to hear that. Sometimes I myself hear from people that you should do teamworks, you should follow your team, but hearing from you that when you are stopped from someone you should do it alone as well, so that's
yeah.
matter. And that's a very good lesson, I think everybody, our listener, will take on with them. So if I talk about this particular Abhyuday team, how did you actually reach to the spaceport American Cup, and what was the story about behind this Chetak one and all? I have just heard it, I just saw it, but I don't know what is the story behind it. So would like to know first
Okay.
from you.
Yeah, sure. So, firstly, I would like to address something that about the teamwork. So sometimes it is necessary that the team working with you is motivated enough, because when someone sees that the project will be completed, when someone sees the possibility, then only they wish to give input. At that time when we started, I mean, there was no possibility that the project will be completed.
Mm.
So I made it happen in such a way that the team got the motivation that yes, this can be done by us only. So that's why the team got motivated, and then we all started working together. We four, and then we hired new members and working together, and we completed the project of the 5 kilonewton hybrid rocket engine. And yeah, coming out to Team Abhyuday, so I was not a part of the team when it was formed. It was formed in some 2018 or that time, and the first time that they were supposed to participate in Spaceport Cup, there was a problem of visa and everything. They made so there was the team, uh, Aditya Edupankti and Ashish Shruti were the team leads when I joined as a volunteer. But before that, they actually built the rocket, the body, and I mean, they were doing all the kind of tests on the rocket, the compression test, everything. But in the very first of the team, because it's very common that the team is new, there were less funding, there was lack of knowledge, and we had to go to USA. So getting the visa and everything within the period, because if you see general wait time for US visa, it's very long. Maybe it can go to a year. But then they didn't know that yeah, we have to apply an emergency visa, and then the time decreases. because in my time I got my US visa in like 2 weeks from application. So, but they didn't know that time. So because of such things, that they were unable to go. But the Chetak one story is the team worked very hard. That time, I think the airframe vertical was very strong. Aditya Meshram, Arin Gangal, they were like, they were great. Their engineering skills were actually very great because I was just a volunteer that time. I was just observing the people in the team, and I saw these people were doing actually a very nice engineering job. It's like one thing is you just take efforts, but your system doesn't work. It fails every time. And another thing is you make the system work. So those were the people who actually made the system work. A lot of simulations, a lot of uh, testing. And my work in the first year was just sanding the fins to and sanding the rocket body so that the fins can go inside. So I didn't do much of work because there was nothing available when I was a volunteer. The team was very new, and they went to. I mean, we were not expecting a good rank in Spaceport Cup America in Chetak from Chetak one because we didn't know anything. We didn't launch in India or anything. It was just the team ran simulations. But yeah, they were very good with the simulations, whatever they did, because they predicted an altitude of around 9,700 feet something, and they reached some 9,500 feet. It was like there is something called as Barrowman ranking. So it's like you have to predict something and you reach something, and whatever is the change is called the error. So our team's error was less than 2%. So we were more than 98% accurate. So that Barrowman, according to that Barrowman, our team's ranking was 16th in the world without any pre-launch in India or anywhere. So that is where I developed a great respect for these two people because of their engineering capabilities. And when the team came back, it was just we had a lot. But yeah, again, that time IIT Bombay, I mean, if you see the overall ranking, IIT Bombay was 66 and IIT Madras was 67. So we were one rank behind them. But no issues because anyway, they were also going for the first time. We were also going for the first time. It's good that both of us did well. And after that, the team got motivated and we started. I mean, I was not working on Chetak 1 or Chetak 2. I was just working on propulsion system for 2 years. And then in the latest rocket, we put our hybrid rocket engine and then we went there.
Okay. So that's really impressive. If I talk about particularly rocket engineering and rocket science, I guess you have done so much of experiment and you know what are the opportunities available not only nationally as well as globally. Because I remember taking a podcast from the SpaceX engineer, and he said that in India R&D is not what is appreciated, but still it's on development process. So what are those opportunity available nationally as well as internationally, which students should start from the first itself?
Okay, so firstly, getting the first internship, I think, is very difficult because you have to prove them your capabilities. So, I will start with the learning phase that I'll just talk about my domain, that is rocket propulsion. So what happens initially is what I have seen is people have no not experience, but less of skills, and then they want to do the job. What I would personally like to advise students is in terms of rocket in the domain of rocket propulsion, if you can do experiments, go for it. Experiments is something which will always give you good experience that you can show anywhere in the world, and people would like to work with you because experimental rocketry is not something which is very similar to theory. It's like the problems that we get is it will never be mentioned in the theory. For example, this hydrostatic test leakage, how to if your system is leaking, how do you arrest it at the moment? So those things are it's like on the spot thinking capability is something which experiments give us. So if you are having a chance to do the experiments, please go for it. Next is if your college doesn't have a rocketry team or a dedicated lab and you can't do any experimental work, then the good thing is go for prediction tools. Because I've seen in the rocket propulsion, people who work with prediction tools get a lot of opportunities because it's directly related to machine learning and coding. So you just have to go through some research papers, take the data from there, and use the equations, code in your laptop, make the models, and simulate and check the results with other engines. It's like you simulate other rocket engines in your code and you check whether the throttling and design, because I did that work in ISRO. So those things are something which can get you for your first internship. When you are done with your first internship, yeah, then I mean, I'm just talking about nationally as of now. Then you can, then it becomes very easy to get second and third and fourth internships. Otherwise, look for startups because there are, I think, in nowadays there are a lot of startups coming in the domain of rocketry, space vehicles, where they need a lot of amateur rocketeers or the students who can do small like CFD work or the NASA CE analysis or some simple Simulink work or codes. So look for startups. Startup has a lot of opportunities, and good thing about startup is you will get to learn more in a startup than a multinational company. So that is where I feel startup is very good for new people, like people who want to learn. And talking about international opportunities, uh, if you want to get an internship, international internship or international research internship, so it becomes a little bit difficult because of the rules of the other countries. For example, in US, it is not possible to get because of the ITAR regulations. In Germany, you can get because I myself am working on a bi-propellant liquid rocket engine in Germany at TU Munich. So research internship is possible, but for that you should have a lot of experience. It's like you have to prove them. I had to prove him in around 3 to 4 meetings that I am capable of working on the system, because what if you go to some international location, they don't want to teach you anything. They want you to know everything. They want to just give you the problem statement and a time limit, and you have to complete it within the time limit. If you can do it, then good to go. You get a good letter of recommendation. If you can't, then they won't give you a good letter of recommendation. So for what I would suggest is first target startups. Once you are done with startup internship, target good places in India like ISRO, DRDO. Uh, and once you are done with that, because in getting in ISRO and DRDO is also very easy. It's very simple. Just have to apply and they generally select if you have good experience. And once you are done with that, then I will suggest you to go to international internships, because if you can show ISRO or DRDO in your resume, they will definitely hire you. So,
Okay. Yeah, so that's a clear path which you have shown, and I'll see to that even I can follow that. And if as I mentioned in your introduction about hybrid propulsion, to
yeah.
me, I personally don't know even the solid and liquid propulsion completely. But talking about hybrid propulsion, how is it different from all these, and what is it in easy term, so that I can understand and the viewers can also, because we all have facts online, but to understand it easily and in short. So can you
Yeah.
just brief on us?
So firstly, solid propellants, they are very risky to work with, because in while cooking the propellant, people lack knowledge. And students definitely they lack knowledge because they have not gone through any course or something, who are working in the domain, most of them. So solid propellants while cooking, if the temperature goes above the auto ignition temperature, because the oxidizer and the fuel both are there. It's like I can explain in simple words. Like you have a candle burning and you cover it with a glass. The candle stops burning because oxygen stops. It means for having combustion or burning, you need two things: something which can burn and something which can support burning, without which you cannot have combustion. So something which can burn, you can say as fuel. Something which supports burning, you can say as oxidizer. So in solid propellants, both the fuel and oxidizer are mixed together before casting the fuel. It means if some spark or the temperature increases, both are there. It can burst, it can blast very easily, or it can undergo combustion, auto ignition very easily. While cooking, if the temperature goes above auto ignition temperature, which usually happens, so it can blast and there can be a lot of disaster, because that has happened in my laboratory. So I can relate to that. And liquids. Liquids are very complicated, very, very, very complicated. You should, because if you see just one diagram, like the schematic of a liquid rocket engine, it will take you a week to understand what all things are there. I had a lot of experience with the hybrid. Then also at ISRO, it took me 2 days to understand properly what that schematic was representing. So liquids, people see they will get scared. So not a good choice initially, and it is not safe also. Because in liquids, if the oxidizer and fuel leaks and it mixes in the atmosphere and it ignites, the whole system will blast off. Hybrids, I will say, in the hybrid rockets, the fuel part that is in solid state, so it is stored in the motor, in the like a solid propellant. And the oxidizer, which is in liquid or gaseous state, for example, just take oxygen, it is stored in cylinder outside. You just need one connection between them, one non-return wall, one check wall, or check wall, and one the flow control wall, so that you can control the flow rates. And you should have an igniter. Because oxidizer and fuel both are separate and far away, there is no chance they can mix together. So no catastrophic like solid. And you have only one connection. So only one fluid coming out. In liquids, two fluids are there. So liquids are very complicated to work. Hybrid, only one fluid is coming out, so it's very simple. Just have to work with one pipeline. And because both are separate, and the casting so hybrid rocket fuel is very simple. It's just a candle wax. You can mix anything in candle wax and it can be a hybrid rocket fuel. So it's that simple. You just have to meditate, because I remember cooking. We just meditate on the induction, put it in the mold. When it is cured after 24 hours, remove it, put it in the motor, start the oxygen flow, fire. That simple. And it is safe also. If you see student rocketry, hybrid is one of the safest systems. So that's what makes me do hybrid initially. Because, and also one more thing is, when you want to do liquid, you cannot directly do liquid. It's very complicated. You start with hybrid, so that you learn about solids and liquids both together. Because in the liquid rockets also, most of the times you have solid propellant as igniter. So you start with hybrid, you get experience about liquid and solid both. Then you go to liquid. If you want to start with liquid, then hybrid can be a bridge, because a lot of international teams does that. So that's why I would say hybrid is a very good point to start with.
Yeah, so at least now I understood somewhat. So that's really great to know about the hybrid solid and liquid difference and the complexity it has. So after all this, if I ask you a simple question personally as a student itself in the second year, do you feel like sometimes when I work upon and I am overstressed with the works, I start hating the things which I loved once? Like I also love space science. Sometimes if it's more than the exceeding level, then I will be like, I don't like this. I don't want to do this at current moment. So was there any moment in your life like that? And if it is so, how do you handle it? Or if it's not,
Okay.
then
So no, there is, I mean, this kind of moments are there in everyone's life. So that is what we call as BTech mindset and a researcher's mindset. I came to know across this term around 2 years ago when I started pursuing research. So there is a BTech mindset, which is like just do the thing. I mean, do as soon as possible. They don't care about the quality. I mean, they care, but not much. It's like just the thing should work. We don't know how, but it should work. If there is problem, we are not much into like solving the like going deep into from where the problem originated. We just want a working system. Like us, like companies, they don't care how it came, but it should work. And researchers' mindset is like you work on something, let it take time. Doesn't matter, but it should be perfect. Whatever things you are putting in that, if someone is asking you of number, for example, my hybrid rocket fuel, there are a lot of students in India. I mean, yeah, there are a lot of PhD researchers in India, a lot of people in India doing these hybrid rockets engines. But they, I mean, most of them I see they randomly make the dimensions of the fuel inner port and outer port. But there is a range. It's like if you ask me why I gave the inner diameter of my fuel as this number and outer diameter as this number, I am able to explain. If you ask me about the pre-combustion chamber, post-combustion chamber, why did I give this particular number, I can explain it. What a BTech mindset says is put any number, let's see if it works or not. If it works, good to go. If it doesn't, then just change and put. But they don't know the reasoning behind. So that is where at a particular point when your system stops working, you get frustrated. But if you know from the basics of everything, because what generally people miss is the basics. They go to higher terms and make the engine, design it, fire it, doesn't matter efficiency and all. Because the first engine that my team built, though I didn't design it, the someone else designed that. I was a part of it. The efficiency was combustion efficiency was 68%, very low. But when I upgraded the design with my research that I was doing, the combustion efficiency was 98.9%. So if you see amateur rocketry, the highest specific impulse that engine gives is generally 180, 190 seconds. My design was giving 214 seconds. And let me tell you, people spend their life to increase ISP by 1 second. So even a second of increase in ISP in the system is very good. So that's what different, I mean, that's what makes me running. And at the points where I am stuck, that nothing is coming, because I have that mindset at that patience level that I go back to my previous work. I just review my work. I see what all mistakes might happen. I do a lot of thinking, and after connecting all the dots, there is a point where I can understand the mistake. I can upgrade the system. But if someone doesn't know the basics, the base from where the work have started, they will get confused and they will not know because they cannot connect the dots behind. So there are missing terms and they cannot connect the dots and come to a point where they can solve the problem. So what I suggest, I mean, because I am avoiding this kind of situation that I am stuck and want to leave. So I am suggesting everyone when you start work, any domain, doesn't matter. You try to learn the thing from the base, from the basic, most basic thing. For example, I can explain the whole hybrid rocket propulsion with a candle burning example very easily. So you can actually relate the things with daily life activities and go to the very basic level and try connecting the dots backward when you start because I still have the notes of everything that I change in my engine. So that's what I would suggest to avoid because such situations comes in everyone's life. But if you want to overcome such situations and don't feel confused, you should know everything from the basics. So let me tell you, basics are very important.
So that's an emphasization of basics, that we should know the
Yeah,
basics. And
yeah,
one more thing from your whole answer, I found that in engineering, there's one more thing, that you should go with the flow as well as do what basics you can learn, as you said. So if we get stuck at that moment, basically go with the flow and learn the basics. That's
yeah,
what I can capture from here. So moving on
correct.
further, after all this, after like till now, I know there are more achievements ahead for you. Till now, after achieving this much, what you have till achieved till now, do you feel like stuck? Like, am I doing the one thing which I wanted, or is it different? Because in childhood we think something different. I personally, when I entered engineering, I thought space science is all about that groundworks, arranging all the stuffs and putting that satellites into places. I watched this Mission Mangal movie. With there, I
Okay.
got inspired. So after that, when I came to college, I got to know that there is a coding part as well. So I got like shaken a bit, and I was like, was I was thinking about this, or I want something else? So was there any how do you like say about this? Are you already doing what you wanted, or you want something different?
Yeah. So let me tell you that during the childhood, I had a dream that I want to make rocket engines. I during my JOSA counseling after JE, I just put IIT Madras in the first place, and I didn't put anything else because my rank was decent enough to get here, and I didn't want to go anywhere else. I got
Yeah,
IIT
wanted
Madras
to.
Aerospace.
Sorry
Huh?
to disturb. Want to know your rank as well, so that
It was
people should.
1,444.
Wow, that's great.
So after getting into IIT, I got my IIT Madras Aerospace on day one of JOSA, round one, day one of JOSA. Yeah. So after getting into here, sorry, what was the question? I forgot actually.
Sorry about that. It was, are you in the childhood, what you thought, are you doing the same thing right now, or you wanted to do something else and you are doing right now something
Yeah.
else?
Correct. So yeah, so I entered IIT Madras. I wanted to do rocket propulsion, and there were no opportunities. So we started this propulsion vertical in Team Abhyuday and created an opportunity. I wanted to do research, so I went to one of the professor at IIT Madras, who is currently leading the rockets and missiles lab. I went to him in my second year. I mean, at the start of my second year, I told I want to work. So he gave me the work because I was very motivated and I was like I studied the rocket propulsion gas and mix everything in first year. So I got the because there was I got the opportunity, but there was no money. I mean, very less money to work with. So there is something called as Young Research Fellow at IIT Madras, which was a source for me to get the money. But the problem is every year from the second year batch, only 16 people get selected out of the thousands of people in IIT Madras. So I had, and there are around 170 projects which are applied, in which a lot of students apply. So it's not guaranteed that even your project will get selected. You might get selected, but the project might get rejected. So I applied for that. I was so motivated. I wrote everything in very detail, and I made it into YRF. So I'm currently in the YRF cohort. So they were the source of funding for me to carry out my research. After that, because there was no opportunity, so I had to create my opportunity. So I created this opportunity of research for myself. Then, talking about this conference and everything, which I'm in Italy now. So I applied for the conference. I got selected. There were two conferences I'm going to attend now. And I also wanted to do international internship. So I I applied for internship in Germany, and my conference is in Italy. So I can, within one visa, I can get everything. And my YRF and some other sources at IIT Madras can take care of funding, because it's like if I go at different places, so I will have to spend more, and I don't know about the reimbursement. So uh, it's like when you do, and for example, I mean, this YRF people, they give funding for the conference part, not for any internship and all. So I had to create the scenario in such a way that I am done with my internship also, I'm done with my conference also, and I get money also. So that's why there sometimes, most of the times, there are no opportunities. But if you are willing to do something, you have to create the opportunity. For example, I always wanted to do liquids. So that's why I started with hybrids. Now hybrids is done. So I'm not continuing with the team anymore, because maybe the vision doesn't align anymore. I want to do liquids, but maybe the team is in a bad situation as of now and can't do liquids. So I do it separately with my international collaboration and lab work. Once done with liquid, I have another mission to, I have another motivation to do on work on RBCCs. That kind of engines are like very rare to work with in the world. Very less people in the world have knowledge on that. I have guides. I know people who have already built and flown that in kind of engines from ISRO, and now are retired. So sometimes you don't have opportunities, but you have to create your own opportunity if you want to pursue what you actually dream once upon a time for. So many people give reasons that there was no opportunity, so I was unable to do that. What I say is there will always be no opportunity. You have to create your own if you actually want to pursue something that you dreamt for. So
That's
yeah, that's
correct.
my answer to your question.
That's such a great advice and such a great motivation that you gave, that you should create the opportunities and all those things will connect automatically. So if
Yeah.
I'm I'm done with the all the questions, and as you are a college student or like the last year student, right? So
Yeah, finally.
would like to ask you some rapid fire round questions so that we can end this podcast with a funny part. So just a second,
Sure.
I'll just ask you. Okay, first question is a book you think every engineer should read on the spot.
Uh, 𝗕𝗫𝗵𝗀 Verma,
Okay, your favorite space movie?
Interstellar,
Great.
and Martians.
Yeah, that's everyone's favorite. If you were a
Yeah,
planet, which one would you be
I would
in
be
the solar
Jupiter.
system? Jupiter. Why?
Yeah, because it saves the Earth from all the asteroids. So if you
Great.
can save someone, then and you can, because of Jupiter, we have the life on Earth. So yeah, why not?
Sure. Most overused space word you secretly hate.
Sorry.
Most overused space word that you
Yeah,
secretly hate. That you don't like people saying it.
scientist. I
Okay.
hate the word, because you can
Okay.
also call them researcher, but scientist is just a fancy word.
Okay. One word your colleagues would use to you. Call. How do they call you?
Oh, maybe a strict guy,
Okay.
because I'm very strict professionally.
A hobby you never gave up even with the busy schedule.
A hobby which I never gave up with my in my busy schedule.
Other than this rocket.
Cycling.
Okay. So that's, I think, a very great to hear from you. Rapid fire was too good. And it made me laugh as well at your answers. So thank you for joining today. I really liked the way, and it was great talking to you. And thanks for joining me today. The podcast was really good, and I personally got very much information from you. And I hope so our viewers and listeners would like it. Thanks for joining us today.
Thank you very much.